Good morning, everyone. Today we will be discussing about group 17 elements, so please listen carefully.
Their colors get darker down the group as they have low ionization energy. Thereby, the electrons get excited by absorbing visible region of light. Ionization energy is inversely proportional to atomic radii, so lower energy light towards the color red is absorbed, so the color deepens.
And as you can observe, fluorine is pale yellow, it's a gas, and chlorine is a greenish yellow gas, bromine is a brown um, gas or liquid, and iodine is a dark purple solid, and astatine is a black solid. Um, for the trend of melting and boiling points going down the group, it generally increases going down the group because the size of the molecule increases due to the addition of the number of shells as you move down each period. Hence, the van der Waals forces are stronger, which requires more energy to break them, and hence resulting in a higher melting and boiling point going down the group.
Volatility, which is defined as the ability to change into a gas under normal conditions, will decrease going down the group. As has been previously said, the melting point and boiling points will increase going down the group, so the volatility will decrease.
The reactivity will decrease because as it goes down the group, the outer shell will be further away from the nucleus. So it has smaller attractive forces, making it harder to attract electrons towards itself.
Electronegativity, defined as a measure of an atom's ability to attract shared electrons to itself, decreases as the outer shell will be further away from the nucleus, so it will be harder to pull the other electrons towards itself.
Barium plus sodium iodide will make sodium bromide and iodine. A purple layer forms on top of the iodine dissolving in cyclopropane.
So for the reaction of hydrogen and the halides, it generally decreases going down the group, and this kind of is caused by the reactivity of the halogens going down the group, which is they decrease going down the group. Hence, the reaction will get less vigorous as the reactivity will decrease going down the group, and the bond strength of the molecules will also decrease.
They will get less thermally stable going down the group, the hydrogen halides, as the bond energies of the halogens with hydrogen will decrease, and this is due to the larger bond length of these bonds.
We can dissolve these ions in silver nitrate solutions and with dilute nitric acid. And for fluorine ions, it will not have a precipitate, while for chlorine ions, it will create a white precipitate. Bromine ions will make a very pale cream precipitate, and bromine ions will create very pale yellow precipitate. When dissolved with ammonia, chloride ions will dissolve, while bromine and iodide ions will remain insoluble. Halogens in cyclohexane can also make distinct colors and will be easier to identify. Iodine will turn purple, bromide will turn orange, and chlorine will turn pale green.
Concentrated sulfuric acid cannot be used to prepare hydrogen bromide and hydrogen iodide, and a mixture of gases will be formed. Like sodium iodide with sulfuric acid will produce sodium bisulfate and hydrogen iodide. Hydrogen iodide and sulfuric acid will produce iodine, sodium dioxide, and water. Hydrogen iodide with sulfuric acid will produce iodine, sulfur, and water. And hydrogen iodide and sulfuric acid will produce iodine, hydrogen sulfide, and water.
Sulfuric acid reacts with hydrogen iodide to form hydrogen sulfide, which has a smell of bad eggs and flammable. Iodine in the form of a violet vapor and water. Sulfuric acid reacts with hydrogen bromide to form hydrogen sulfide, bromide in the form of a brown gas and water.
So let's talk about disproportionation reaction. It's a redox reaction in which an element gets both reduced and oxidized in the same reaction itself. Now for the element chlorine, it undergoes a disproportionation reaction with sodium hydroxide. And when you're using a cold alkali, which is at 15 degrees Celsius, you will get sodium chloride, sodium chlorate, and water as a product of chlorine reacting with sodium hydroxide at 15 degrees Celsius. However, when you're using a hot alkali, which is at 70 degrees Celsius, you will be getting sodium chloride, sodium chlorate, and water. And if you can notice, for even though the names are quite similar, but for the sodium chlorate at the hot alkali, there's like a subscript 3, which kind of shows you that the oxidation state of the chloride is different in that reaction compared to the one before. So yeah, that's all for our presentation today. Thank you for listening.